So, today's discussion is on designing cold weather clothing. Now, first we need to know what are the requirements in cold weather clothing. The requirements can be classified into 4 groups: functionality, ergonomics, durability and maintainability. From the functionality point of view, what is important? As listed in this particular diagram, you can see it: protection from cold because it is winter. So, that is very a primary requirement, followed by protection from wind, that if somebody moves out of the residence, then the wind may be blowing. The other thing is protection from rain, because there is a possibility of rain in winter also, and protection from snow wherever it is snowing. So, these are the mainly functionality point of view, these are the requirements. Ergonomics point of view, it should be easy to wear and take off, it should be quick in nature, then it should be comfortable, and comfortability depends upon so many other parameters. We have just listed 2 important parameters here. One is the weight of it, it should be light in weight. Heavy garments will not like, and the other thing is breathability, that one should not feel suffocated after wearing the clothing for a long time or for a short time. The suffocation feeling should not be there. There are other ergonomic requirements which will come, that is, it should not restrict the movement of the limb also. So, that way it has to be designed that the person should be able to work. Then the other requirement is durability, and if we look at this, that is the wear life. Then the color fading, if the color fades, which will affect the aesthetics part, even people sometimes may reject, because even though functional point of view the product is still okay, but it may be rejected because it is no more looks good. The other thing is strength of the various joints. There may be several joints, because we will be taking so many pieces of fabrics which will be sewn together to make a garment. So, whatever joints are there, these joints should not fail, and therefore, the strength of those joints and wherever buttons are there, these should not fail also. If they fail repeatedly, then also you can say it is not a durable one. And then comes maintainability, where ease of washing is important, that is, whether can I wash it in a washing machine or not. The other thing is easy drying, how much time it takes to dry. There could be situations when lot of time may not be available for drying. So, quickness of drying also could be an important requirement sometimes, and the last one in the maintainability is the storage, that how it can be stored, can it be stored easily, or do I need special boxes to store it, whether it will be infected by various types of insects or not. These are the various issues which comes when we think of designing cold weather clothing, and each and every aspect has to be taken into consideration. So, here now we find there is a table, and in the table I have listed property of the fabric and property of the garments in the columns and the requirement is there in the very first column. There are 4 important requirements we have listed already: functionality, ergonomics, durability and maintainability. Now, if these are the requirements, what are the property of the fabric and garments which are relevant, that we need to know. So, this is therefore, if you look at the functionality from the fabric consideration, what is important is thermal insulation of the fabrics that we are going to use. Then comes air permeability, water penetration, and these are related to the fabric, and then what is there is related to garment now, like the design architecture of the garment, the overall design concept that we have, that will also be important from functionality point of view, followed by weight, size, then the closures, various closures, closing system that we need to design, and these are the important aspect from functionality point of view. Ergonomics point of view, what matters is the weight of the fabric, the weight of the garment as well, the porosity of the fabric also becomes important. You may feel cooled very fast if the structure is too much porous in nature. Then the other thing is, what matters for ergonomics point of view is design, architecture, weight, size, fit, closures, bulkiness of the garment, finally how bulky it is, then freedom of limb movement, whether you can really move your limbs easily or not, ventilations, whether ventilation is there so that you can feel comfortable. These are the issues which will be important from ergonomics. Ergonomics takes care of mobility of the various limbs that we have, especially hands and legs. The person has to walk, so he has to turn, he has to twist, he has to scout sometimes, he has to, depends upon the kind of nature of the work that person is doing. Then durability, if you think that what properties of the fabrics or the garments are relevant from durability point of view. Now, durability mainly depends upon strength, tear strength, abrasion resistance. Strength basically means tensile strength, color fastness, and the closures that we use. There are different ways or different types of closures that is used nowadays. So, all of them can have some influence on the durability of the clothing and maintainability. So, some properties you see listed. It is not that this table is complete in all senses, one can add also. The moot point is that we need to understand that whatever functionality or ergonomics or durability considerations are there, what properties of the fabric and the garments are important, so that we take care of all those issues in order to produce a clothing which will suit the requirement of the customers. Now, we need to do some pre-designing research in such situations. And what is this pre-designing research? That is, what is the activity level of the users that we need to know, indoor or outdoor, whether he is going to use in indoor situations or in outdoors. Indoor and outdoors are obviously will need different types of design. In the indoor, you cannot expect too much of wind blowing over you, or you may not expect snow or raindrops falling on you. So, things are different there, whereas outdoor you have to consider these aspects also. Then comes the possible metabolic heat generation, which also depends upon the activity of the person, that all of us, all human beings is continuously generating heat, we call it metabolic heat. So, the quantity of heat that we generate depends upon our level of activity. The other thing is the duration of activity. How long you are going to work at a stretch? Is it half an hour work at a stretch, or 1 hour or 2 hours? All depends upon the professions. And here on the right hand side we see there is a table which gives you some idea about the different types of activity and the heat that is generated because of these activity. Even in sleeping, our body generates 70 watt of heat. Resting, it is 90 watt of heat. If we walk slowly, 140 to 175 watt. Walking, you can say brisk walking, 4.8 kilometer per hour, 280 to 350 watt we generated. If we do cycling, some values are given there. Hard physical labor, 445 to 545 watt. Depends upon person to person. So, a range has been given. If somebody runs 700 to 770, sprinting 1400 to 1500. So, you just to show that it all depends upon the level of activity and the body generates more and more heat. The vigorous is the nature of the activity. The other thing is we have to map the environment in which the person is going to stay. Therefore, conditions of the workplace, if somebody it has to be used while someone is working, then the conditions, the weather conditions we need to know, that is temperature, humidity, air movement, all these informations will be important. And the general weather pattern also we need to know, that how the way, because something which is used to be used for a certain period of time, maybe for a period of 5 months, 6 months, 2 months, depending upon the duration of the winter. In some countries the winter is there throughout the year, in some countries it is for 6 months, somewhere it is 4 months, 2 months. So, whatever it is, wherever it is, depending upon the market that we are going to target, whatever is produced for Indian market may not be suitable for European market, because the type of weather which is there is different. So, we need to get some data from related to climates. That is, here just as an example we are showing that how the temperature varies in New Delhi, India from January to December, the minimum and maximum temperature. So, we get an idea typically how the temperature will vary throughout the year. So, anything that we produce, we need to know when somebody is going to use it, and depending upon that the proper design can be made. So, this is one thing. The other one is the humidity, which is also another graph given next to it at the bottom. Then there is a sun hours, the sunshine will be there or not, and how it will be, that is also given here. And then precipitations, which will be there or not, whether it will rain or whether it will snow. These data we need to collect in cases where the government plays a very critical role from the point of view of survival of the person who is going to use it. So, all of them needs to be keep in mind, and where it may not be so important, we may some of them can be ignored also. Then wind speed is also given throughout the year. The rainy days are also given here. All these data is going to help. Some climate data we need to find out and consult. Now comes the detailed designing process. Now, when it comes to detailed designing process, one needs to know first items that are needed in the ensemble. a person is going to wear an ensemble, not just one jacket. So, the ensemble, what are the different items of the ensemble, we need to know that. Then comes the garment design specifications we have to develop. That means, we need to know the design drawing, how the garment will look like, how many parts will be there in the garment, where we should have seam and what type of seam, all these detailing has to be there, the design drawing has to be there, because it helps in communication. See, designer has to communicate with the production team. Now, this communication has to be such that whatever is there in the mind of the designer, the production team should be able to grasp it, able to understand it. So, from communication point of view, we need to draw some diagrams, because diagrams gives a very very quick method and very you can say that the ambiguity will not be there if we have diagrams for communication other than the text material which will be there. Then come the dimensions, the various dimensions of the various parts of the garment, component size and locations. If there are various components that is used, then what are the size, where they should be located. Then joining methods, buttons, zippers, tape or seams, whatever it is, all these needs to be worked out for to develop a design specifications, and this specification then will go to the production team who will actually then produce the garment. Insulation of clothing items, that is, what is the insulation value of the various clothing items that are going to use, which can have some role to play in the overall insulation of the ensemble. Air permeability of the clothing system. It is not just one single fabric that will matter. The ensemble consists of layers of fabrics. So, we need to know permeability of the clothing system as a whole, and moisture vapor transmission is another aspect. Whether moisture vapor transmission will be easier or it will be restricted, because it will have lot of influence on the comfort aspect of the winter garment. So, all of them needs to be considered for detailed designing. Now, here what we see in this diagram or this table, that a typical example of an ensemble is given here for winter season. Like ensemble 1, the list consists of underwear with shorts, sleeves and legs, plus a shirt, plus trouser, jacket, heavy quilted outer jacket, overall, socks and shoes. This gives a total clo value of 1.85. Now, see, each of these items have their own clo value, and there is a standard which is available. So, I will come to that standard just now. We will see that if we know the clo value of individual items, and then we can sum them up to find out what is the total clo value. Another example is for ensemble 2, where underwear with short sleeves and legs are there, shirt, trouser, jacket, heavy quilted outer jacket, overall, socks, shoes. Two additional things which are here are caps and gloves. Cap also has certain insulation value, it can protect, it can keep you warm. Gloves also has insulation value. So, the next ensemble, therefore, the clo value is more than the previous one. rest of the things are same, only gloves and cap, if we add, the clove value changes by 0.15. An example we have given it here, like different items, individual clove value, we add them together, we get what is the total clove value. So, this is a very simple way to find out the clove values, like as I told you that there is a standard which is available by SRA, and these standards says that typical clove values of different types of garment items are given here. Underwear, various types, corresponding clove values, shorts and blouses, various types, corresponding clove values, these are given. So, these have, there are many of such items have been tested on a mannequin, and a standard values have been made, and which can one can refer to develop an ensemble which will suit a particular the requirement of a person. So, many items are there, you can see a list, sweaters are there, jackets are there, high insulating fibers pelt are there, outdoor clothing, coat, down jacket, various items, corresponding clove values are here. So, if this list is there, it goes up to 40, so many items and corresponding clove values are given here. So, if we can think of a list of items, the clove values, if we collect from here, put them and sum them together, we get an idea that the total clove value will come somewhere here. So, the point is that how much clove value is required to keep a person comfortable, that needs to be worked out. That is, in a given situation, how much clove value will be required to keep the person comfortable. That calculation is different, but that also needs to be worked out. If we have these values, that so much insulation 1.8 clove value or 2 or 1.4 whatever, if that is what is required, then we can choose the items, so that the entire body is covered. That is the condition that we put, and we will be able to find out that if we go by this values, we will be able to find out the total clove value of the ensemble. It is possible. The other things are of conditions for thermal comfort are that body must be in heat balance, mean skin temperature must be within a comfort limit, no sensorial discomfort due to prickling, itching, smoothness, clinging, this should not be there. And ergonomics point of view, garment fit, garment weight, freedom of movement, aesthetics, all of them will be very, very important. And the basic equations of thermal comforts are stated here. M minus W, I think we have already learnt about what M means, what W means in some previous lectures. These have their usual meaning, and M minus W is what is stated here. So, heat stored is this much, A minus W minus E S K plus R plus C plus K minus S. So, there are three possibilities, that is how much metabolic heat you are producing, and then how much work being done, and these are M minus W should be equal to this. So, that the heat balance is always maintained. If S is 0, heat is perfectly balanced. that is whatever I am producing, the same amount I am losing also. So, heat loss should be such that it is not that we are not allowing heat to be lost. Even if we put some garments, heat will be lost finally, and equilibrium will be established and some heat will flow out always. So, what is important is that the amount generated minus the work done, that should be equal to heat that I can release from the body with the garments that we have. So, when AC is 0 or close to 0, it is perfectly heat balanced, the person will feel very comfortable. If AC is greater than 0, then heat will accumulate, that is heat is gradually going to accumulate, and over a period of time the skin temperature is going to rise, the person will start sweating and the discomfort sensation will start. It will not happen immediately, the body can to some extent tolerate when AC is little more than 0 or AC little less than 0. So, there is a tolerance within which the body may still feel comfortable, but if we cross that threshold values, then heat will accumulate with time and skin temperature is going to rise, and therefore, we will start feeling uncomfortable, the person may start producing sweat. Sweat will give additional problem to the designer, because it is a liquid which is there on the skin. What do you do with the sweat? In the sweat, most of it is basically water, and we know that water is a good conductor of heat. So, the sweat remains on the skin and or it goes into the layer of fabrics which is close to the skin. The thermal insulation value is immediately going to go down. So, heat loss is going to be faster. So, this is one very important aspect in the designing of winter clothing. And if the AC is less than 0, that means I am losing more, and therefore, person will start feeling also discomfort will be there, but skin temperature will now fall from the comfortable temperature. So, this will give another kind of sensation, shivering will be there after some time, that also needs to be avoided. So, this is what is important. So, therefore, main design objectives are heat balance, moisture management. Body is continuously generating moisture. So, this moisture is actually we will not be able to understand or sense the generation of moisture, we do not feel it also. Unless moisture gets converted into a sweat, we do not realize that our body is generating moisture. But anyway, the body continually generates some amount of moisture, and this moisture is going to always it is moving out of the body and getting mixed with the surrounding air. So, moisture management is important, prevents of wind penetration. Moisture from outside should not penetrate, and moisture from inside, that is sweat, insensible perspirations, also needs to be managed. So, moisture management has two aspects, either it is a entry of liquid from outside in the form of raindrop or splash of water or snow. Someone wants to suppose cross a river, so water is there, so that water should not be able to penetrate. Similarly, moisture from inside is basically either sweat or insensible perspirations, which is always there with us. So, all this needs to be tackled. Consequence of moisture accumulation with the garments, as I have already mentioned, that moisture absorbed by garment causes discomfort and adds wet carried by the persons. it reduces thermal insulations of the layer, and when activity drops, sweating ceases. The drying of wet clothing layers deprive the body of more heat than generated. The result is post chilling and lead to hypothermia. When a person is therefore working with the clothing on, then it is okay, but when the activity drops and sweating stops, the drying of the wet clothing layers deprive the body of more heat than generated. So, wet clothing layers inside then creates problem, because the body will be trying to lose the heat faster, because the layers are wet now, the water is there. Since there will be sensation of post chilling and can lead to hypothermia. As long as one can stay dry, the choice of material, natural or synthetic, for various layers is a matter of taste or other preferences and requirements. If we stay dry, the choice of material, whether natural material or synthetic, is a matter of taste only, and other preferences are required. Other preferences could be, let us say, I want a very lightweight garment. So, therefore, I have to use fiber which is low density fiber. So, we have to look for fibers which is low density, and if we think about the fibers which are low density, from the fibers we will find polypropylene is low density, acrylic low density, polyester is low density. So, these are the fibers which are low density fibers, and therefore, they will be suitable, because the weight also matters. And the other requirement could be that we have to dry it faster, or the moisture or the water has to be released fast. We have to can squeeze out. There could be situation when the entire garment is wet, one needs to dry the garment very fast. So, we can squeeze and extract most of the water and then put it for drying, so that within an hour or two it gets dried. In between we do some other thing, we can wrap it around our body to keep ourselves warm. So, such kind of exigencies could be sometimes there. Therefore, quick drying also could be a very important requirement in certain situations, especially those who are going for trekking or those who are working in the hills. This could be a very important consideration for them. With the possibility of sweating and long outdoor exposures, strong, lightweight, hydrophobic material therefore is suitable. As I mentioned, in such situations, the hydrophobic material could be, that means polyester or acrylic or polypropylene. These fibers will be suitable in situations like outdoor exposures. How liquid sweat is generated, we need to know. Sweat starts when skin temperature reaches 37 degrees centigrade, and sweat evaporates on skin and is transmitted to the environment through clothing. So, ideal condition is water vapor flow from skin to fabric, and the vapor will flow from fabric to environment. This there should be balanced. So, whatever vapor is flowing from skin to fabric, the same amount should always escape from the fabric to the environment. That is a ideal situation, but generally that is what does not happen. Condensation of the moisture can happen, because moisture from skin goes to the garment layers, and we have whatever layers we have, the moisture will be there in those layers. So, when the local partial vapor pressure is greater than the pressure of saturation, the condensation will occur. That is, the moisture will be converted into liquid. That possibility is there. And amount of condensation depends upon water vapor permeability and thermal resistance of the clothing. These two decides the water vapor permeability. Condensation depends. If the vapor permeability is high, the condensation will be less, and thermal resistance of the clothing also is important. So, condensation may occur. So, designer has to keep in mind that this is a possibility in certain situations, and therefore, the clothing must be able to protect the person even under such situations. Then now, how the moisture can be controlled or regulated? So, there are three mechanisms which are important for controlling the moisture. One is absorption, ventilations, or transportation to the next layer. That is what is only possible. Absorption is reduces skin humidity and retain relative comfort. We can absorb the moisture from the skin, but moisture will remain in the clothing and may be detrimental to heat balance at later stage. So, if we have a suppose a layer of fabric next to our skin, which is very good from the point of view of absorption of moisture, then whatever moisture is getting generated, it is getting absorbed, because I have a layer of fabric surrounding the skin which is absorbing the moisture immediately. So, skin will remain dry. So, one can think such kind of situation may be very good. That means, I must have a layer of material which will be able to absorb the moistures. So, we have to look for fibers which can absorb moisture quickly, but it may be detrimental to heat balance at a later stage, because if the moisture it absorbs, but it does not release fast, then moisture will accumulate, and after some time the moisture may get condensed into water, and then the trouble will start, because now suddenly the insulation value will go down. So, these are the problems which will come. Initially it may be helpful for some period of time, but later on when someone has to wear these for a long period of time, then it may be detrimental, because it will hold the moisture which may get transformed into a liquid, because you will reach a saturation level after some time, and now once the liquid formation is there, the insulation value will suddenly drop down, the fabric surface will try to cling to the skin, and discomfort will be there. The other thing is transportation. Placing hydrophobic textile next to the skin quickly increases humidity and moisture is transferred to the outer layer. Now, one can think of hydrophobic material near the skin. Now, hydrophobic material if we place near the skin, the negative point is because it does not absorb the moisture. So, the moisture will accumulate between the fabric and the skin, and that microclimate will get saturated with moisture very fast, and the person will start feeling discomfort, because whatever is getting generated, the same amount is not crossing the fabric barrier at the same rate, and hence moisture is going to accumulate between the fabric and the skin. So, you will start feeling discomfort very fast. That is the negative aspect of this, but the advantage is moisture is transferred to the outer layer, because it itself will not hold the moisture, it can allow the moisture to go to the next layer, provided the next layer is a layer which can absorb the moisture. So, we have to be very carefully decide about the fiber that we need to use next to the skin. And the other thing that is possible for control is the ventilations, that is in ventilation, ventilation will be there in the garment design part of it. So, now the garment design becomes important, that we must have ventilation. So, the wearer opens the clothing and ventilate the microclimate, which is full of humid air and sweating with sweating. It is used in resting and low activity sports. So, here if the fabric, the garment is designed, not the fabric, in such a way that we have many vents. So, there are many cuts here and there. In that case, we will be able to take out the moist air, the saturated moist air next to the skin, and the person may feel comfortable, because accumulation of the moisture next to the skin is a source of discomfort. So, in the garment design or the uniform design, the ventilations should be there. Now, the question will come, why we should have ventilations and how much ventilation should be there. Ventilation needs some kind of opening. So, the opening should be such that you should not allow the air to come in, neither you should allow the rain, in case it rains, to get inside the uniform or the garment. So, these aspects has to be also kept in mind while designing the ventilations. In the design guidelines, therefore, what are important points is build up layers of protected air and void spaces, because I need more insulations, and insulation mainly comes from void spaces. So, this is important from point of view of insulations. Insulate the body core, provide ventilation features to avoid overheating, protect air or void spaces from wind and water, keep the clothing clean. All of them should be important as a part of design guideline. So, we have build up layers of protected air or void spaces, because whatever voids are there, voids should not be such that the air can easily enter. Otherwise, the cold air from outside may easily enter, penetrate the garment, and in fact, create it will cause heat to be lost very fast. That is what is not there. So, the void is required, but the void needs to be protected from the entry of air or entry of rainwater. Therefore, the protected air and void should be there. Insulate the body core. The core part of the body needs more insulations. So, another aspects which are important to know, from which part of the body maximum heat is lost. So, the part from where maximum heat is lost needs to be first taken care of with suitable insulations, and the part which holds vital organs. So, this is the part where vital organs exist, and from where the maximum heat loss possibility could be there, we have to protect it more than the other parts of the human body. That means, the kind of insulation that we need for the trunk part of the body where heart is there, lungs is there, and the part like legs or hands. So, the level of protection that you need or insulation that you need will differ. It is not that the kind of protection or the insulation that we need for the trunk part of the body and for the hand part or the leg part should be exactly same. They may be different. So, different parts of the body will need different level of insulations. This is what is important. So, we need to know that. So, these are, if you want to go detailing, there are many more aspects. Provide ventilation features in the design, as we discussed just now. Protect air and white spaces from wind and water. Keep the clothing clean. Yes, is also important that the clothing has to be kept clean. If it is dirty, it will lose its insulation value. So, in the layering principle, what we do, the clothing with multiple layers provide better protection than equivalent single layer, because between layers there will be a layer of air, and that layer of air is going to further enhance the insulations. So, multiple layers is better than a single layer garment, very thick single layer garment. Detachable layers are preferable, as the insulation can be regulated by removing layers if necessary. This is another way to reduce the insulation value if it is required. The outermost clothing layer should be loose, so that inner layers are not compressed, which may decrease insulation. This is also important, that for the same person the outer layer should be larger in size, so that it does not compress the inner layers. Compression means change in thickness, change in thickness means reduction in insulation value. The inner layer must provide insulation and be able to wick away moisture from the skin to keep it dry. That is important, as I said, that otherwise there is a chance that it will reduce the insulation value, the water is going to reduce it. Outer jacket must contain methods of closing and opening. Certain sections such as hood, neck, front body panel and sleeves, which can be removed to regulate exchange of heat. So, we can have such thing like hood, in the neck something, front body panel, if we can have a provision, so that some parts of the garments can be removed whenever we require, then it will help us to regulate the loss of heat from the body. That is to maintain a heat balance. That is how a person can be, can feel comfortable. Insulating body core. The body core, that means the trunk part of the body where heart and lungs are there, other vital organs are there. This part has to be insulated, and we have to be more careful about this part of the body. Here the important things are adding a layer of insulation in the areas of the body core, head, neck, torso significantly reduces heat loss from the core. So, this is what is the research findings, we have to keep it in mind. A hat, scarf, t-shirt adds considerable warmth. From the head we lose lot of heat. So, if we have a hat or a cap, it can have a very high insulation value and can give us considerable warmth. Insulation need not be uniform over the entire garment. That is what I just told you, that different part of the body requirement of insulation may be different, and accordingly we have to design the garment. Insulating core to the point where excess heat builds up and triggers vasodilation in the extremities allow the design engineer to minimize insulation where mobility is required. Now, this is in a way helpful, because if the insulation requirement near the hand is less, then I can have a thinner fabric there or a thinner ensemble which will be thinner in nature, and that will help to move the limbs easily. Otherwise, if we have a very thick layer everywhere, in the torso part, in the hands, in the legs, then movement will be very difficult, mobility will be less. Fortunately, the parts which are further away from the heart, they need less insulation. So, any part which is furthest from the heart, they need relatively less insulation. So, the fabric or the layer of fabrics or the thickness of the fabric that you require in those regions will may be little thinner than what we require near the torso, and that is also going to help in terms of mobility of these limbs. Other important thing is identify areas where greatest heat transfer to the environment can happen, and if possible place thick insulation there, so that it does not interfere with the movement. So, that means torso is the right is the place where the maximum heat loss could be there and vital organs are also there. So, we have to have a thick insulation near the torso part, and the torso does not move in comparison to other limbs. So, there is no difficulty in having a thick layer of material there. Insulation to be placed over the coat which stores lot of heat or over large blood vessels close to the skin surface. So, these are basically the guidelines. Areas around joints should be lightly covered to allow freedom of movement. So, wherever we have joints, let us say knee is a joint, then elbow is a joint, then wrist is a joint. So, in these areas where joints are there and we have to ensure that the joints can move easily. So, the placement of the fabric which will be used or a layer of fabrics which will be used in these regions, they can be little thinner, or so that the freedom of movement is allowed. So, this is also important that, and if you see that if you check with any jackets which are used by let us say the army or navy, you will find that the designs are such that the placement of material or the thickness of the jacket is not same everywhere, they are different. Ventilation features for regulating overheating, because we do not know, sometimes there could be overheating because of too much of work that the person is doing, or maybe the insulation value is so high that it can lead to overheating of the body and the skin. So, ventilation points are collar, cups and belts are some structural features that enables ventilation when loosened. If we lose, then lot of air can escape. Netted pockets, vents around trunk, under armpits, sides can be used. Excess body heat can be taken away, conduction, convection, radiation, by allowing access to skin surface or inner layers of the clothing. And ways to regulate is, if an individual begins to feel warm, head should be partially uncovered. When you start uncovering, in order to regulate the heat that our body is generating, that we started feeling uncomfortable, we should start removing the head cover first. If it is a hood, hood should be removed. If it is a cap, can be removed first. So, head should be partially uncovered, and then neck area, upper front or back. This is how we can regulate the body heat. So, we can, if we open them out, heat will escape quickly from the body and you will start feeling comfortable. Opening of a garment should be loosened, so that warm air can easily escape. So, if there are some other ventilation points, they should be opened out. If there are buttons, if there are chains, we remove them. So, we open the garment and allow the heated air to escape fast. Loosening wrist areas or sleeves may also help to ventilate due to pumping action during walking. There are the many ways that ventilation can occur, and that will give you that will bring comfort. Protection of void or air spaces from wind and water. The outer layer should be wind resistant and waterproof, so that cold wind cannot penetrate and accelerate heat exchange, and water cannot penetrate to fill up the void spaces and thereby lower insulations. So, the outer layer should be windproof and waterproof. Accordingly, the outer layer has to be designed. Cleanliness, as dirt fills air pockets within the garment, it destroys their insulating ability. Dirt facilitates growth of bacteria also, leading to very bad odor. So, therefore, the garment needs to be cleaned from time to time. Architecture of winter clothing garments, if we now discuss, that is the design architecture. In general, it should consist of 3 layers: inner, middle and outer. Layers can either be inseparable or separable from each other. So, the way we should have inner layer, outer layer, middle layer, that they can be separable from each other. In some cases, or the designer may think of putting all of them together also. So, both type of designs are possible. So, options are there, depending upon situations, either we can make them separable or inseparable. Now, inner layer, if we now go into detailing of this, what are the requirements? Being on the skin, it controls microclimate, temperature and humidity. So, being next to the skin, the layer should be soft and stretchable, because it is coming into contact with the skin. The prickliness should not be there, and it should be soft in feel. With low activity, the layer must reduce air movement. It should not allow the air to move, otherwise there will be convection currents will be generated and heat loss will be faster. With high activity, heat and moisture should be transported from the layer to the cool the skin. If the activity level is high, then obviously lot of heat will be generated, and at the same time moisture will be also generated, and these two needs to be transported faster to keep the skin cool. So, that means, the layer also should have the ability to transfer heat and to transfer moisture. So, you see these are the so many requirements. It should be soft, it can be stretchable, and at the same time it should be close to the skin. There should not be too much of gap between the first layer and the skin, and at the same time it should be able to transport heat and moisture if required when the activity level goes up. These are the requirements, and based on these requirements we have to think what kind of design we can have. Fabric should not retain moisture, as it would increase conductivity. This was already told earlier also. Under no circumstances, the very first layer which is close to the skin should not hold the moistures, because it will increase conductivity and that will create problem. Okay. Options for moisture removal. So, we have seen that moisture accumulation and absorption by the very first layer is a problematic for us, and therefore, we have to always see that how can we tackle this moisture that we have generated, and the difficulty is the moisture level generation is not constant, it is a function of activity. The other thing is heat is also getting generated there. So, heat also depends on the level of activity, and therefore, it is the same fabric layer which will be there has to tackle both moisture and heat. Inner base layers would have a texture or hairs on the interior surface to attract liquid moisture from the skin and wick it away. In case there is a sweating, we have to take out the liquid moisture. So, wicking property of the fibers becomes therefore important. It will wick away and it can be sent to the next layer. Constructants would facilitate removal of sweat by differential capillaries pressure. That becomes a very important guidelines, that how do we take out the moisture from the inner layer to the next layer. The only mechanism that can be employed is capillary pressure, there is nothing which is there. So, we have to think of formation of layers where capillary pressure will be differential capillary pressure can be utilized to take out the moisture from the skin to an area which is little away from the skin, and therefore, the air in contact with the skin can remain dry. Hydrophilic finish on polyester or PP would initiate moisture attraction and allow it to be transported by wicking action. So, this is what is possible, that is hydrophilic finish on polyester or PP. This has been tried. Now comes the fiber selection for the inner or base layer. So, some guidelines have been discussed, some issues have been also discussed, and now when it comes to selection of fiber for the inner layer, how do I select the fiber? Cotton, if it comes to our mind, then the answer is it has to be avoided. It is acceptable when perspiration is low. If the perspiration is low or almost nil, then we can use cotton for the inner layer without much problem. In fact, it will give us more comfort, but when perspiration is high, cotton gets wet, clings to the body, thermal insulation will reduce, and therefore, in higher activity level, cotton cannot be used in the inner layer. In hot climate, cotton with high thermal absorbability is perceived pleasant, but opposite in cold environment, because this possibility could be there. Now, comes synthetics. With synthetic base layer, sweat is removed faster from the skin. That is the advantage will given, because fibers itself is not going to absorb anything, nothing is going inside the fiber. Whereas, the pores which are there, the capillaries which are there between the fibers, these capillaries will be able to take out the sweat from the skin very fast and will be transported to the next layer. Merino wool and wool polyester mixture as the base layer fabrics also have been tried, and it has been found to be quite good, but merino wool is very costly. Otherwise, this can also be a good idea to use wool, merino wool and or wool polyester blend. The wool could be mostly merino wool, which is quite fine, and therefore, it is not going to create prickliness with the skin. A coarser wool means that there will be a lot of prickliness sensation, and it will not be so good in terms of feel and comfort. Here, we have given a comparative chart we have made in terms of normal or synthetic fibers which we should use for the inner layer. So, wool, cotton and synthetics are there. As discussed, cotton absorbs moistures, clings to the skin and should not be too close to the skin in cold environment, provided situation is such that the person is going to sweat. Wool and wool blends, it possess high absorbing capacity and can handle small amount of moisture without losing insulation. It can be used next to the skin fabric and keep the skin dry. When the fabric gets saturated, the moisture control is reduced. Wool does not melt and hence suitable for military use. That is one of the very, in case of fire, especially in military situations, that the wool is not going to melt, whereas polyester or any other synthetic fiber is going to melt, and the fabric is going to stick to the skin, and that will give lot of burning sensation to the wearer. So, that is the danger that we have in the case in such situations, whereas wool will be quite good in such situations. Wool, we all know, it is self extinguishing fiber, and that is the best part of wool. Synthetics are hydrophobic and moist air can move from skin through the fabric to the next layer. So, not only moist air, it is can be the sweat can also move faster. The skin microclimate quickly becomes humid during sweating, that is the only negative point. The microclimate will get humid very fast, but initially whatever moisture skin is generating, the layer of fabric made from synthetics is not going to absorb it. So, it is going to accumulate there, and as once it reaches saturation point, the sweating will start, and that will lead to discomfort. So, quickly a person is going to feel discomfort, and that is the only there is negative aspects of synthetics. So, what should be the type of fabric? The construction could be either knitted or woven. Knitted is better because it will extend easily and conform to the complex body shape, and hence for the very inner layer next to the skin, knitted construction is better in comparison to woven, because it can extend easily, it can conform to the shape of the body. This is the advantage. Now, middle layer we will discuss. Function of the middle layer is simple, it provides mainly insulation. So, it comprises of one or several garments of thicker material. Non-moisture absorbing material such as polyester, polypropylene, acrylic should be selected for long term exposure with limited heating and drying opportunities. Here we should use non-moisture absorbing material, and therefore, all synthetic fibers, polyester, acrylic, PP are the three fibers which can be used here. Any textile can be chosen as long as it gives insulations, but the advantage these fibers are that this is the lightest and these two are also very light, their densities are much less than cotton. Polyester could be 1.38, polypropylene 0.91 density, acrylic could be I think around 1.14 or 1.18, somewhere there. So, these fibers have this advantage that they are light weight, they are voluminous, but their weight is their weight will be much less in comparison to cotton. Material selection for thermal protection. Thermal conductivity of the fiber lie within narrow range. If we look at the thermal conductivity of fibers which can be used, you will find that they all lie within a very narrow range. Fiber should not absorb moisture. So, conductivity point of view, we can say any fiber can be chosen because their conductivity values are not very different from each other, but we have to also take in consideration other properties as well. Fibers should not absorb moisture. Fibers should have a low density to make the garment light. Fibers with bulking potential and resilience are to be chosen. This is also important. It should be resilient, that if I compress it and release it, the garment, the thickness should be able to retain the thickness and the possibility of bulking, because bulky material can hold lot of air within it, and air is a source of insulation also. So, that way bulking potential of the fiber should be important, resilience also is important. Fabrics are basically mixture of air and fiber. Fiber dominates in weight and air in volume. The thin air layer surrounding each object is relatively resistant to movement and known as boundary layer. Each object, or you can say each garment here, the layer of air surrounding each, you can say each layer of the garment. If I have an inner layer which is separate, if I have a middle layer which is separate from the inner layer, then in between inner and middle layer there is a layer of thin layer of air. Similarly, between middle layer and the outer layer there is a thin layer of air. So, these layers surrounding each of these layers they are known as boundary layer, and this layer also contributes towards the insulation value of the ensemble as a whole. Air is the most important factor for insulation. You all know this, so this is not nothing to be said again. So, if we look at the properties of this typical fibers which can be used in the middle layer, cotton, polyester, acrylic, polypropylene wool, and if we list the relevant properties from the point of view of insulations or from the point of view of the requirement of the middle layer, then it should not absorb moistures. If we look at these fibers, cotton is no, cotton absorb moistures. Water resistance, Y means yes, no means no. You see, in most of the property which is desired, cotton is no almost for everything. So, therefore, cotton cannot be used in this particular layer. Other fibers you have a chance, all of them have some chance to be used, and if we get hollow fibers, they are very good, and so polyester, acrylic, polypropylene wool, anything can be used to some extent, and they are used, but polyesters are very cheap or polypropylene is cheap. So, they are mostly used, and if you get hollow polyester fiber is still better. So, hollow fiber is still better. So, whenever we get a hollow fiber, either polyester hollow fibers are commercially available, and therefore, they can be used, and the wool was also hollow in nature, and that is the advantage that why wool is also give lot of warmth, because wool is also hollow. There is a medulla, and where it is hollow, the air is there. So, polyester, hollow polyester can also be very helpful. So, cotton cannot be chosen, but other fibers can be chosen for this layer, and the middle layer could be textile like or duvet type. Duvet type basically means the kind of design is shown here, or textile like means it could be knitted, it could be pile fabrics, it could be a fleece. So, either this type or this type or this type or this type can be used, and all are being used. Only you have to know for a given situation which one is better, but all of them can be used. With pile and fleece fabrics, thickness is limited, that is with these two. For extreme cold, duvet type layers is preferable. This one which is preferable for extreme cold. How to enhance insulation? This question always comes, especially for designing extreme cold weather clothing. That is, with normal fibers and normal designs, sometimes we may not be able to achieve the insulation that is required in extreme cold weather. One is that varying fiber cross-sectional shape and trim to trap more air. So, one can use not round shape fiber, but fibers of which are non round in nature, or which are more having more crimps. Idea is it will create more pores, and therefore, it can trap more air. Hollow fibers can also be used to improve insulations, they will trap air. Wool gives higher insulation because of 3D crimp and medulla which is there. Polyolefin microfiber reduces radiation loss. So, microfibers can be also used because this will reduce the radiation heat loss. Heat loss we will come to now, the 3 ways the heat can be lost. Radiation is one mechanism through which body heat is lost. So, we have to also see how to reduce the radiation heat loss, and there a porous structure is not good, and hence beyond a certain porosity if we go, heat loss will be faster, but if you reduce porosity, then we may find sometimes that insulation value is going to increase. We will come to that immediately just now. See, then down feathers of birds also can be used. Reflective material, aluminized fabric or fibers can be used to reduce radiation heat loss from the body. So, these are the various ways to improve insulations. Now, fiber diameter effect on radiation loss, because the question will always come that if we want to have a what type of fiber we should choose, and then what should be the fiber denier or diameter, what should be the cross sectional shape. All these issues will come when we go for the detailed design process. In general, radiative heat loss decreases with decreasing fiber diameter. Radiative conductivity, we know this formula, and from there we can see that fiber radius is important. The conductivity, radiative conductivity will be more if the radius of the fiber is more. Now, this is what has been shown by some researcher, that fiber diameter versus radiation conductivity. It has been plotted and shown that if the diameter increases in this range from here to there, with increase in diameter the radiation conductivity is increasing. So, larger diameter means more loss, less insulation. But from here to there, this range, let us say this could be around 5 or so or something like this. What we find? With increase in diameter, the radiation conductivity becomes less and less. That means, in this zone the effect of diameter is different than in this zone. Here, when the diameter is large in this zone, larger diameter means more conductivity means less insulations. In this zone, more the diameter increases, that basically means the conductivity becomes less and less, insulation value becomes more and more. Therefore, what is written here? Therefore, smaller diameter fibers are more effective in scattering the radiation back to the hot emitting surface. As diameter of the fiber increases, the scatter effectiveness decreases. Radiation conductivity values of microfibers, which are in the range of 5 micron to 10 micron, is equal to the radiation conductivity of microfibers between 0 to 5 microns in this range. So, therefore, if we there is a minimum fiber diameter below which radiation loss decreases and which is somewhere here, somewhere let us say around 5 or 6, we get radiation conductivity which is minimum, and therefore, the loss is also minimum. It is when the diameter approaches the wavelength of infrared radiations, this is where then the radiation loss becomes minimum. So, that is a effect of fiber diameter on the radiation heat loss. See, radiation loss from the human body is a very major component of heat loss. The conductive heat loss is there, convective heat loss is very negligible, but the conductive loss is there and radiative loss is there. So, we have to take care of radiative loss also, and there the diameter of the fiber plays a very important role. So, there is a certain diameter which is less than 10 micron. So, suppose in this zone we have a range of fiber diameter which is coming from here to there, when we get very low conductivity and therefore, less loss of heat. So, the fiber diameter we choose less than 10 or around 5, 6, 7, 8, maximum 10, because very fine fibers sometimes difficult to manufacture, but if we go for fibers which are 5 to 10, we will able to have a sheet of material which will be having which will minimize the loss of heat, especially the radiation heat loss will be minimized. So, therefore, the effect of diameter is very important to know. Some more facts to remember: all insulating material loses 2/3 insulation when wet. Normal cotton fabric retains 3 times more water than polyester. Wool does not retain much water due to natural hydrophobicity. Wool, the surface of the wool is such that it is highly hydrophobic in nature. The scales are there and they do not absorb moisture. So, if you drop some water on the wool, it will simply slide down, but it can absorb moisture. The moisture regain of wool is very high, much more than cotton. So, moisture it can absorb slowly, but water drops, it will not absorb, it will simply roll down. Through squeezing, most of the water can be removed from synthetics easily, but this cannot be done so easily from cotton. Now, the last part is outer layer. The function of the outer layer is to provide protection against environmental factors such as wind, rain, fire, tear, abrasion, etc. So, you have to take care of all these aspects while thinking of designing the outer layer. The layer can add to the total insulation by provision of insulation liners and battings. So, it contributes to the total insulation value of the ensemble. So, requirement becomes waterproof, hydrostatic head around 28 meter, seam should be sealed to make it waterproof also. Windproof, air permeability should be less than 5 liter per meter square per second. Permeability should be there, so that requirement is evaporated sweat should be able to escape. Water vapor permeability is, the formula is given here, 1 by RET into latent heat of evaporations, and I think we have discussed these issues into these things earlier in our lectures. Waterproof property can be achieved by applying coating and by lamination. So, the last layer that we make it, so many requirements. How to make it waterproof? That is by coating and lamination. By choosing a fiber which is also hydrophobic in nature, we can choose polyester, which is anyway hydrophobic in nature. We can choose nylon also, which is also not as hydrophobic as polyester, but it will also absorb very less moisture. Otherwise, we can use a nylon fabric and then coat it by some material, or we can laminate it, and thereby we can make it quite waterproof. So, that the rain drops cannot really penetrate and enter, or if somebody is going through some river, he has to cross a river or something, in that case also the water should not be able to penetrate. Evaporative resistance, some values are given here, and classification in terms of very good, good, satisfactory, just to give you an idea that what type of resistance could be there. Fabric used for outer layers, lightweight wide nylon over garments for snow covered landscape. In that case, the color becomes important. If people are working in a area where snow is there, so as a camouflage one can use this wide nylon fabrics. But at the same time, it gives difficulty to recognize, to identify a person if he is in danger, he or she is in danger, because very difficult to locate. The color will be exactly same as of that of the snow, but for camouflaging it has to be white. If you want to spot it from a distance, then orange color is very good. So, in that case orange color nylons can be used. Finely woven windproof cotton fabrics could be used outer layer. People have tried it. Polyester microfiber fabrics can be used. Windproof, waterproof, water vapor permeable laminates are there. These are microporous laminates. So, we will discuss a bit of microporous laminates or microporous membrane. It is a very thin walled structure having an open spongy morphology with interconnected pores ranging from 0.03 to 10 micrometer. So, pore size are very small and introduced into an impermeable polymeric material, which could be PTFE, polyurethane, polyolefins, polyamides and polyester. So, this is microporous membranes are available now. Typical weight is 10 to 20 gram per meter square. So, very thin. It is durable, resistance to laundering chemicals and UV degradation, this has to be seen. Now, through it vapor molecules being smaller can penetrate the pores. The size of a water molecule is much smaller than the size of these pores. Water drops cannot penetrate due to large size. And why they are large size? Because in water the molecules are held together by surface tension, and therefore, the size of the water drop is larger. In the vapor form it is very small. So, the vapors will be able to pass through this micro pores, but not the water molecules. So, these membranes have been designed and they are used also. One of them is all Gore-Tex fabric, and if we the diagram cross sectional view of the Gore-Tex fabric is shown here. It is a 3-layered fabric actually. The inner layer is a soft flexible fabric and which is warp knitted. So, the inner layer is here at the bottom. The outer layer is a abrasion resistant fabric, usually woven nylon. So, on the top is this top is woven nylon and the lower this is basically warp knitted fabrics, and in between we have the PTFE film. Combined GSM is 182, that is gram per square meter, it is wet, and then thickness is around 0.42 mm, ends per inch and peaks per inch of the open fabric is in 100 ends per inch and peaks per inch around 72, and wells per inch or courses per inch was found to be around 23 and 35. So, these are some constructional values of the Gore-Tex fabric which are used in many applications, especially where we have to protect a person from raindrops, but we have to allow the vapor to pass through. This is a very commercially successful fabric, and actually it is a composite fabric consisting of the PTFE film which is there at the center. You can see it here, the PTFE film at the center, very thin film, and on both sides of it we have 2 layers of fabrics. It is a sandwiched fabric therefore, and this can be used in the outer layer. With this we close this particular topic. So, I have given you the various aspects or the various issues related to the designing of an winter clothing. So many aspects therefore needs to be considered while you think of designing a particular item. As I said, the ensemble is there, where there are so many items are there, including the designing of a socks could be there, designing of the gloves could be there, designing of the cap could be there. These are not normal day to day design item. If we have to think of a design for extreme cold weather clothing, then there each of these items also needs to be taken care of, especially their designing part. A normal socks will not give you a kind of insulation value that normally we need for a very extreme cold weather clothing. So, all those items which a person is going to wear, we have to keep it in mind, and we have to think of designing each and every item. The part that we have discussed here is mainly focused on, you can say, the jacket part of it and the ensemble starting from the very first layer to the middle layer to the last layer. But as I said, a jacket can only cover a part of the body, rest of the part of the body also needs to be covered. The trouser has to be designed properly, the gloves has to be designed, the hat has to be designed. So many more items are there. The socks has to be designed, the shoes needs to be designed properly also. So many items are there, everything has to be designed properly. So this design exercise is a very huge and big exercise, and only some guidelines have been stated, and I hope that this will actually excite you to know more and more about it, so that you can yourself come out with a proper design solutions. Thank you.